All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD 1112 Application Programming with Java class, I've been doing a series of video presentations. There are 2 books for the class, and I'm presenting from the first book, Java Quick Syntax Reference. It has 23 chapters, of which 22 are in this PDF, and I am up to Chapter 18 on abstract. All right, and I want to give you my take quickly on abstract. Okay, now if I were to have come in, there would really have been no reason to do this, but going back to my old code here, if I'd have come back and said public class, in fact I want to make sure I'm giving you the right syntax here. Okay, if I'd have changed that from public class to abstract, if I'd have done that, I'd get an error back in my calling class, the my class 2, because you cannot create an instance of an abstract class. Now, do I expect that to totally make sense? No. So let's talk about it from a higher level perspective. I'm not sure what they'll say in the book, all right, but I want to give you my perspective of it. So imagine that somebody comes up to you and they're all excited, and one of my students, and I say, well, what's going on? And they say, I just bought a new pet. I said, a pet? Yeah, I bought an animal. Well, what kind of an animal? I bought a dog. What kind of a dog? I bought a German Shepherd. All right. Notice with each one of the questions, I'm getting more and more specific information. But if somebody says to me they have an animal, all right, I'm not going to make an instance of an animal class because it's too generic. So I might make a class, an abstract class called animal, and in that abstract class, I can define any variables and any methods that all animals will have. But I cannot create an instance of that class. It is abstract. Now, if a class is not abstract, like the ones we've been making so far, they're typically referred to as a concrete class. So you'll notice here I've got an abstract class called shape. I had mentioned this to you before, that even though I went up at this the way the book did, which was to create that rectangle class, and then we extended that for triangle. I would have created a shape class, all right, then I would have extended that to rectangle and also extended the shape class to triangle. All right. So what this says is any class I cannot new or instantiate a shape, but I can make a rectangle that extends shape, and I can then new or instantiate that. So if a class rectangle inherits from an abstract class, it must have an X and a Y, and it has them automatically, but it must implement something that's called getArea, and it must return an integer. Now you might look at that and go, well, this looks just like what we just did, and what we just did was we just talked about interfaces. Well, it's different. You can still only extend one abstract class, whereas you can implement multiple interfaces. Plus, if this was in an interface, these would be constants. Down here, they're not necessarily constants. All right? An abstract class cannot be instantiated, but it can be used to hold instances of subclasses. So I can create a shape class. Based off of that, I can have a rectangle, a triangle, a cube, or whatever it is I want. Each one of them can extend shape. Each one of them will automatically have this stuff available to them. So I've already mentioned this, but I'm going to say it again. Abstract classes are similar to interfaces in many ways. Both define method signatures. that any subclass that either extends or inherits from the abstract class or implements from the interface must implement, and neither one of them can be instantiated. The key differences, it says, first, abstract classes cannot contain non-abstract members. Abstract classes can contain non-abstract members. An interface cannot. Second, a class can implement any number of interfaces, but only inherit from or extend one class, regardless of whether that class is abstract or non-abstract. All right. It says, note that an abstract class can, just as a non-abstract class, extend one superclass, and it can also implement any number of interfaces. However, an interface cannot inherit from a class. All right. An interface is used to define a specific functionality that a class can have. An abstract class, on the other hand, is used to provide a partial class implementation and leave it up to the subclass to add or complete what needs to be added or completed. All right. We have reached the end of another lecture here. I'm almost done with this. So before I go on to enums, chapter 19 of 23, I'm going to pause for a moment.